Hey everyone! In part A of this problem, we're looking for the angular acceleration of the Potter wheel as it accelerates from rest to an angular speed of 1 revolution per second. Recall that the formula for angular acceleration is equal to a change in angular velocity divided by the time interval that it took for that change in angular velocity to take place. This is also equal to the final angular velocity minus the initial angular velocity divided by the time interval. We're told that the final angular velocity is 1 revolution per second, and it starts from rest, so the initial is 0. And we're dividing it by a time interval of 30.0 seconds. This is the same thing as saying 1 revolution per second divided by 30 seconds. If we put this into a calculator, then we find an angular acceleration of about 3.33 multiplied by 10 to the power of negative 2 revolutions per second squared. But the problem asks us to write this in radians per second squared. So let's convert from revolutions to radians. So that's 2 pi radians for 1 revolution. And if we put this into a calculator, we find that this is equal to about 0.209 radians per second squared. And that's the answer to part A. Part B asks whether doubling the angular acceleration would double the final angular speed. We can figure this part out logically simply by looking at the equation we used to solve for part A. If we rewrite this angular acceleration equation to solve for the change in angular velocity, then we can see that the angular velocity is equal to the angular acceleration multiplied by the time interval. So as we can see, the change in angular velocity is directly proportional to the angular acceleration, meaning that if we were to double the angular acceleration, and this doubles the entire expression, and we're led with double the change in angular velocity, which means the final angular velocity will be twice what it was before, or rather twice what it would have been in part A. So the answer to part B is yes. Doubling the angular acceleration would indeed double the final angular speed. And that's it for this problem. I hope this video helped you out. If it did, please consider subscribing, as it'll help me out in making more videos like this. And if you have a question, leave a comment down below and I'll do my best to help you out as best as I can. If you have a request for a future video, or you just like to hang out, my Discord server and my Twitch page are linked in the description below, so check those out if you'd like. But that's all for now, and I hope you all have a lovely night. Bye-bye.